Mr. N going over the Math 5, quiz number 10, Pascal's triangle and parts of rational functions, the asymptotes, horizontal and vertical, taken February 21st, 2020. They all said version H, but the real version you'll know is by the capital letter up here. And so I'm going to call this version H. Multiple choice directions, circle the best answer. A rational function is a quotient of two polynomials. That is true. It is the division of two polynomials. Number 2. Which of the following is not rational? So if we know that it is a quotient or division of two polynomials, here's division of polynomials, yes, yes, yes. Now this one does show division, but polynomials have to have an exponent that is a whole number. So 1, 6, and your base is a letter X, or cannot be a number. Here, C is not rational because if you take the exponent is to the first power and then the index is 2, the radical is basically 3x to the 1/2 power. And this is not a whole number, therefore C is not rational. Question number 3, given the graph, what's the equation of the horizontal asymptote? This would be a horizontal asymptote. But it doesn't appear that the graph has a horizontal asymptote. Maybe up here, you're not sure. So the answer would be none of the above. Not very clear from the picture. Number 4, using the graph above, so using this graph, fill in the blank for the end behavior. So as x approaches positive infinity, that's over here. So as we go towards this direction, what is the graph doing? It is going up. We're not sure how far up, so the answer is positive infinity. As x approaches negative infinity, that's going towards the left. What's happening to the graph? Again, you're looking at the arrows. The arrows are the end behavior of the graph, and again, we're not sure what's happening, but it's going towards positive infinity on the y values. You must start with a positive infinity and end with a negative, and then those are your answers, 1 point apiece, so 2 points for this line, 2 points for that line. Question number 5, multiple choice. Use the graph of the rational function shown to complete the statement. And it was kind of hard to see, but it was down here as x approaches positive infinity. So as you go towards the right, what's happening to the graph? So here you have a rational function graph that looks like it has 2 vertical asymptotes and 1 horizontal here. And as you're going towards the right, what's happening is this graph right there is landing or approaching a number, getting close to, on the y-axis, that would be 0. So it is approaching f of x values of 0, which is b. Question number 6. Which function matches the graph here? And hopefully you didn't pick D. I mean, this was last year, Math 4, Math 3, even beginning of the semester. This is a quadratic. That's a power of 2. So no division there, nothing. This one is, hopefully we're going to do this next. This is called the square root function, and the graph looks like that. So it's not C or D. Your choices are between these two, and the activity we learned earlier when we were learning this is that rational functions, division, and odds are split, and evens are together above or below the x-axis. So your answer is going to be B. And then question number 7 says, using the graph above, write the range in interval notation. The range is going from the bottom to the top. Now, as I come down from the bottom here, there is no graph on the negative. So from negative infinity, there's nothing, 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 and then it starts right here on the y-axis at 0. So the graph is from 0 towards negative or positive infinity. So parentheses 0 to infinity again. It's a parentheses because you're not including the x-axis. Let's look at some student work here. Draw your attention to the student work here on question number 7 And remember, the ranges go from here, but I just want to show you what this would look like if we did this direction. They're saying positive infinity to 0. True, but you have to go from the bottom to the top, and then they go from 0 to negative infinity. So their mistake is that, yes, there is a graph from here to here, but there is no graph from 0 to negative infinity. And then you're not going from top to bottom, you're going from bottom to top. I gave this student half credit because there is no graph there, but this one was correct, so I gave it 1 point. All right, back sign, make sure to show all your work and box your answers. Question number 8 says, expand 4x minus 3 to the 4th power. I'm kind of showing you this work first because number 1, you'll see my answer key that this part got deleted, but you could write this out 4 times, and that's why I gave this student 2 points. Student can do more because you actually can simplify it. I did mine as a plus b to the 4th power, a plus b to the 4th power. And then you can use your Pascal's triangle here. And then you're looking at this row right here. And because it's to the 4th power, I need to write the coefficients 1, 4, 6, 4, 1. 1, 4, 6, 4, and there's the 1. And then the a value to the left, you're going to start with a 4. So a to the 4th, a to the 3rd, that's an a squared, a to the 1st, a to the 0 power. And then the right side, the b values, b to the 4th, b to the 3rd, b 2nd, b to the 1st, and b to the 0. And then what you're going to do is you're going to eliminate anything that's 1. You just don't have to write it. It's redundant, not needed. So that one's not needed. Remember, anything to the 0 power is 1, so that's not needed. You don't have to write that one. This was just a to the 1st. We already know that. And then you don't have to write this one. Then your a value is going to be 4x. And you'll notice that the substitution I did there is in parentheses. A value is 4x. And then every b value is going to be negative 3. Again, in parentheses. That one I don't need. And then 4x times 4x times 4x times 4x gives you 256x to the 4th. Again, you're going to use PEMDAS, so 4 cubed, 64 times 4 times negative 3 gives you negative 768. And then x to the 3rd power is just x to the 3rd. You'll have negative 3 squared, which is positive 9, times 16 times 6 is 864. And this x here is only squared, so it's only going to be x squared. Negative 3 to the 3rd power is negative 27 times 4 is negative 432x. Remember, this x here is to the 1st power. It's not x to the 3rd power. That would be incorrect. And then negative 3 to the 4th power is 81. How did I score that? You also got 2 points if you did like 4x minus 3 and you distributed the 4. Remember, negative 3 to the 4th power. I would have accepted that. Or this one. This is something correct. Essentially, this is not, but you're multiplying the first and last. If you got just the A's and B's here in blue, I gave you 3.5 points. If you substitute in for the A and B's, like I did right here with the parentheses, but you did not simplify it, or you're super close, I give you 3.75. Or if you just wrote the coefficients, 256, 768, 864, 432, and 81, then I gave you 3.5. Let's look at some student work. Here's a student. Oh, that's interesting. The student had 4x minus 3, but they were given this. Oh, where did that come from? Oh, that came from the other version. All right. No, that's the wrong one. All right, this student was going in the right direction. They just needed to write out 4 of these and keep going. For some reason, they stopped. Not quite sure why. I gave them 2 points for going in the right direction. All right, this student expanded it 4 times, and then they multiplied these first 2 and got 16x squared minus 24x plus 9. And so they recognize that if this represents 2 of them, then this would represent the multiplication of 4 of them, and they got the correct answer. All right, this student got their A's and Ooh, this is interesting. This is not b's. I think they knew they were going to substitute in -3, but then they'd eventually put it into parentheses. Well, they had b here, and then the -3's. I gave them 3.5 because they did the substitution, but their simplifying was incorrect. 4 to the 4th power is 256, but x to the 4th power is x to the 4th. So they're missing their exponents, and essentially all they have is just the coefficients. And then, interesting enough, somehow in their answer they got a y variable, and I don't see any y's whatsoever in the problem. And then they do this, so at least they gave them some credit for that one. All right, given the following graph, complete the table over here. So vertical asymptote is in yellow. And how do you get that? You just pick some ordered pairs on there. And you will get, I picked 0, 0, 0, 1, and 0, -1. And you notice all of my x values are 0. That's why you must write x equals 0. If you wrote 0, I gave you 0. You have to have a variable there. That's why you practice it all week. Now, if you mixed up the vertical and horizontal, like x equals 2 or y equals 2, I gave you 0.5. Domain means going from the left side to the right side of the graph. Question is, do you have something over here? And you do, because of the arrows. You have something, and then there's a break, then you have graph, and then all the way to infinity. So I have -infinity to 0, not including 0, and then union or connection with 0 to infinity. That's how you got your 1 point. If you have a constant in there that's not 0, they give you 0.5, or if you got one of these intervals, maybe 0.5. Horizontal asymptote is way up here. What is that value? It is 4 boxes, 1, 2, 3, 4, but it is not 4. It is a 2, y equals 2. You know that because every 2 boxes it says 1. So 2 more boxes, that's 2. 2 more boxes, 3. Again, the horizontal asymptote, I just picked 3 order pairs on there, so that's 0, 2, 1, 2, -1, 2. And essentially that's the equation of a horizontal line. All my y values are 2. I gave you 0.5 if you wrote x equals 0 or y equals 0. The range is going from the bottom to the very top, and you have a part of the graph here because there's the arrow. So you have something, and then the graph stops here on this dotted line, which is your horizontal asymptote, and then continues again above it. So -infinity to 2, and then 2 to infinity right there. Again, if you miss that number there, then I gave you 0.5. And behavior, if you got the red box correct, that's automatically 0.5. You have to have 1 positive, 1 negative in that order. And then what happens is, as x approaches positive infinity over here, this plane here, this graph is landing at 2 on the y values. Y values 2. And then as you go towards the left, what's happening? You're also landing at 2. So if you got all that correct, that's a 1. Remember, if you got the box correct and your constant was wrong, like these numbers, then I give you 0.5. Let's look at some work. All right, so missing a variable, then write the range. Oh no, your infinities are turning into 8s. Oh no. The student didn't recognize their end behavior. Remember, there's a, let's see if I can highlight that. There is a yellow box. And it's always the same, 1 positive, 1 negative. And then the last part of is your can fill in the blank square so that each row and each column contain all the digits 1 through 4. Numbers in the cages may repeat as long as they are not in the same row or column. So for example, they're repeating numbers, but they're not repeating horizontally or vertically. There's your freebie. Start there. Put a 4. That means you need the numbers 1, 2, and 3. Anytime you have these 3s or triplets or the corners, you see it 1, 2, 3, 1, 2, 3. A lot of times those are repeating numbers. So 3, 3, and 1. Guess you could do something like 3, 2, and 2, but I need two numbers that divide to be 2, and then two numbers divide to be 2, so I get 4 and 2, 2 and 1. Three numbers are 4, 3, and 1. Two numbers that subtract to be 2, that's 3 and 1. And then these three numbers multiply to be 16, and you'll see no repeating numbers. If you got this one all correct, or these four numbers, I think the only difference is that down here you could have just maybe switch those numbers. Yeah. I gave you 4 points, and then 1 point if you were wrong, and a blank gave you a 0. The backside was worth 13. And if you go to the front side, whoa, what happened? Uh-oh. 13 on the back side, 16 on the front. Let's double check. 4, 5, 6, 7, 8, 9. 9 plus 4 is 13 on the back side. So 13 on the back, and then we count on the front. 2, 4, 6, 8, 10, 12, 14, 16. So that is correct. So 13, 16 plus 2 should give us 31. Am I wrong? 16, 13 is 29. 29 plus 2 gives me 31. So this should be out of 31. Good luck.
Math.
Say it again.
Our math.